Now, I like to list out the functionalities that we need to implement in the contract. So, these contracts we are starting with has the features to collect flash loan from aave v3 and repay the flash loan. So, the first thing has been implemented. So, the next feature we need, which is number 2, is what we discussed earlier, which is to supply tokens as collateral with flash loan and borrow against it, against our collateral. The next one feature we need to implement would be for us to repay. We should be able to repay the borrowed amount with flash loan. That's the next one we need to do. So those are the two major ones, but there are other necessary features that will help us to achieve those two strategies to achieve that. The first, which will be our number 4, would be, since we are going to be working with Coinbase Ethereum, it's not going to be easy for us to get Coinbase Ethereum. We can easily get wrapped Ethereum. You know from the previous video that whenever you are testing in your test environment on Foundry, it will always set up a local blockchain for you, which is called Anvil. In this case, our Anvil is a fork of base mainnet. What fork means is a copy of base mainnet. That means that all the deployed contracts on base mainnet will be available for us to interact with in our local machine. So we are going to be playing with the fork mainnet. Now, Anvil would now also give us 10,000 Ethereum to play with. It's fake money, it's not real money. So we are going to wrap some of it and convert it to wrapped Ethereum. Now, we are going to be able to, we'll now have to swap this to Coinbase Ethereum. So we need to be able to interact with aerodrome v2 to swap. So that will be quite important. Features we need is to also be able to supply tokens to Moonwell without flash loan. So should we be running out of collateral and you have some tokens to protect your capital, we should also be able to deposit through the contract. Then we'll also, if we want to increase our borrow and we have more collateral to do that, we should also be able to borrow. So those are the two features we need to add. So over here, this is our major strategy. So this is, if we come to this execute operation is a function that will be called by aave protocol. So when we call repay supply assets with flash loan, it's going to start the process of taking the loan from aave pool. So it will call to the pool contract, aave pool contract here. And in response, the aave pool contract will call back to our contract and it will call this execute operation function. When it does that, it will perform everything in this function and repay our loan here. This is where it will repay our loan. Now, so we need to implement our strategy somewhere here before it repays our loan. So we would need to use the money. At this point, we already have the money, so we have to use it before we repay it. So this is where we're going to do that. This is unnecessary, so I'm going to delete that. It belongs to what we did in the first, in the previous video. Now, we have this. Now, the final thing we also need to set out is we need to interact with two contracts or protocols, and it's Aerodrome V2. Aerodrome V2 is a decentralized exchange, and Moonwell, the protocol where we'll be yield farming. These are also smart contracts. Now, for you to interact with a contract, a deployed contract, you need two things. The first thing is ABI, or the interface of the contract. I'm going to explain what that means. And the number two thing you need is the contract address. Now, think of contract address as the address of the contract you want to interact with. Address, like street address. So, like address of a company. ABI specifies those you can talk to in that company in order to get whatever you want to do done. So the manager of the company, the receptionist you can talk to. So this is what ABI, application binary interface, defines. All right. Now, ABI is a bit of a lower level. The one easier for us to interact with is the interface. So the interface of the contracts looks something like this. This is the interface of worth token. So it defines all the functions available for us to call. So this is compiled down by SOAK to it's compiled down to the ABI of the contract. So we need to get that. We need to get ABI, or the interface of Aerodrome V2 and Moonwell. So let's proceed and get that now. Here we are on Moonwell website again. So what we want here is to get the documentation of the Moonwell protocol. So just come here. When you click this, you're going to see the link to the documentation. Just click it from the drop-down list. Now it takes us to the documentation of Moonwell. We are going to scroll down and see where the contracts addresses are. It's here now. Yes, I've seen it. So we have the contract. We are interested in base contract address. Now we'll be interacting with this controller contract. So I'm going to click that. It's taking us to where it is on base scan on the blockchain itself. Here on the blockchain itself, if you click this contract button, now we have the contract itself. All right. So for us to see all the functions available for us to interact with, in fact, it's actually an upgradable contract. So I'm going to click this write as proxy. So it's going to give us all the functions we can talk to on the proxy contracts. I'll talk about upgradable contracts in my future videos. So here are the functions. Claim reward. You can in the last in the part one of this video, we talked about claim reward. These are the functions we're going to be calling. All right. So we'll also need to call some contracts on read as proxy. I've written out the interface, and let's just jump back into the IDE. I just wanted to show you how to get the contract on the block. I'm going to come to this interface folder. I'm going to create a file. I'm going to name the file iMoonwell. This is where we are going to keep all our interface. So iMoonwell. So over here, I'm going to write all the interface we need. Now, as I said, we needed to interact with the controller contract of Moonwell. So these are the functions we are going to need in that contract, and we're going to be interacting with them. Now, I'm still going to come back to mToken interface. Aerodrome V2, we interacted with these contracts in multi-dex arbitrage bot video. If you haven't watched that video, please go back and watch it. Now, we got from aerodrome documentation, we're able to get all the functionalities that we needed to interact with. So feel free to pause the video and write all of this down. And these are the interface we are going to be interacting with. Now let's import this interface into our contracts. Then we can now be calling each functions as we need them. Now we come here and we are going to write import all the three interfaces. As I said, I'm going to explain IAM token interface later. Now let's try and implement this first. Interact with aerodrome v2. The first thing is for us to get the contract address of the aerodrome routers. Aerodrome v2 routers are what we are going to be interacting with. So these are the contract address. If you go through aerodrome documentation, you're going to get this contract address and aerodrome factory. It makes sense to have these two as constants for two reasons. Number one, their values will not change. And number two, because of gas fees. Now, when the EVM is compiling these contracts, whenever it sees a variable, it creates a memory slot for it. And the cost of creating a memory slot is 20,000 gas. That's quite expensive. But once it sees a constant, it doesn't allocate a memory to it. It just include it in the byte code. So we spend no gas at all for storing these constants, and especially for the fact that they don't change. Now, the same thing applies to immutable variables like owners here, the owner variable. It allows us to access the owner variable once in the constructor. So we assign value to the owner variable in the constructor. And once we do that, the values remains constant. So it's more like it doesn't allocate a memory slot to it. It just includes it in the byte code. Now let's move on. We have our contract address. We also have the interface. I'm going to create an instance of the aerodrome contract here now. I'm going to call it aerodrome router. Now, this instance to complete this instance, we need to also wrap it around the contract address. So this is how that works. We need the interface and we are going to wrap it around the contract address. Now I'm going to do this in the constructor function. In a couple of seconds, I'm going to explain the constructor. So this is how we'll do it. This is the router address. Now I've successfully create an instance of the aerodrome v2 contract. Now, the constructor is a function. In fact, in many cases, it's not considered a function because it's not callable. Now, it only runs once when you deploy this contract. So the EVM, whenever you see the keyword constructor, it sees it as a function. It needs to run once when you're deploying it. That means that all of the variables inside this constructor will be assigned once, and that's all. So since we just need to instantiate this contract once, it makes sense to have it in the constructor. For us to swap on aerodrome v2, let's look at the interface again. Now we need to call this function swap exact tokens for tokens and supply all these parameters. Then we also need to specify get amount out. I'm going to explain how that works. And also this is part of the parameter. This is a struct. and we need to supply all these parameters in this struct. So let's come back here and write an internal function to swap. Here is the internal function to swap on aerodrome v2, and quickly I'm going to explain the steps. The first thing is whatever token, which is this token in is the token we have, and we want to give it to aerodrome v2 as a, so that's token in. Then token out will be what we want to receive in exchange for the token we are supplying. So token in can be wrapped Ethereum, and token out can be Coinbase Ethereum. That's what we want to swap to. Now we need to approve aerodrome v2 router to take this token from our contract, and amount in is the amount we are going to specify for it to take. All right. Then on the interface itself, the route um the route here, just 1 second here, the route struct, we need to specify these 4 parameters. So this is how we are going to specify it. Create an instance of it called route. Then we are going to specify token in, token out, which are the input parameters here. Then they are not stable coin. Because they are not stable coin, we write false. And aerodrome factory address that we got up here, that we specify up here, it's part of the parameters required. Then amount in minimum. Now this gets amount in a couple of seconds. I'm going to explain that because it's quite important. And amount mean. Now amount mean is the minimum amount we are willing to collect in exchange of what we are supplying. So what that means is, if I'm supplying one wrapped Ethereum and the price is 1, that means that I'm supposed to get 1 Coinbase Ethereum in exchange for it. Now the price can change when the swap is going on. Don't forget this is AMM. Now, so when it changes, the price can go as low as anything, and it can go as high as anything. All right. Now we need to specify to aerodrome v2 that if the price changes with this slippage and the price becomes it goes against us, and instead of getting 1 Coinbase in exchange for our 1 wet Ethereum, we can only get, let's say, 0.9 Coinbase worth. We'll tell, with our amount out minimum, we are going to tell aerodrome to cancel the swap. All right. Now, if it could also move as much as even 50%, that instead of getting 1 wrapped Ethereum or 1 Coinbase in exchange, we'll get as much as 0.5. Now, this happens because there are bots. We call them MEV bots, whose job it is to ensure that you get the worst possible price for your swap. So that's why it is important that you have to specify the amount out minimum. Find this get expected output error. Then you'd see how it helps us to calculate our amount out minimum. So this is it, get expected output error. Now this function calls get amount out minimum, get amount out on aerodrome contract. Now this get amount out is a function on aerodrome that simulates your swap. So if you want to swap worth to Coinbase ETH, based on the current price, it tells you how much you're likely going to get, which is the amount. So it returns that to our function here. And based on the slippage amounts we have specified, we can now say, okay, we are expecting to get 1 Coinbase for 1 wrapped Ethereum. Our slippage is 1%. That means that you can't give us anything less than 0.99 of Coinbase ETH for our one wrapped Ethereum. If it's worse than that, cancel the trade. All right. So the next thing is for us to define this slippage and the whole percent and the duration. Duration here helps us to define the deadline. So we need the swap to take place within 2 seconds. Otherwise, the aerodrome router should cancel our swap, because if it takes too long, then the price would also move on us too. So these are part of the input parameter for aerodrome, for swap tokens, for tokens. All right. So let's define the slippage. All right, let's define the slippage up here, over here. Now you can see I just defined 0% and not in a normal way. The whole percent should be 100%. But with solidity, solidity does not understand decimal points, 1.2 or 1.7. It doesn't understand such things. So what we have to do is to use big integers so as to remove those decimal points. So instead of using 100%, I'm using 10,000 multiplied by 10 raised to the power 6. So this is how you write 10 raised to the power 6. Now, you can as well write this as 10 raised to the power 10. It just makes it easier for me to see that I'm working with 10,000. So this represents a whole percent. Now, slippage. Now, you want to specify that your slippage should not be more than 0.5%. 0.5%, it's 99.5. So if you multiply that by 100, that's 9,950 multiplied by 10 raised to the power 6. So this represents the slippage of 0.5%. If I want 0.1%, then this will be changed to 9, and this will be 9,990. But let's keep it at 0.5%. I think that's fair enough. Now, our slippage we should be able to adjust our slippage depending on the market condition. So let's write a function to allow us to change the slippage. Now here is the function: set slippage tolerance, and the number is multiplied by 10,000, right? It takes this parameter, which is unit 256. This is how unit 256 means it's an integer. All right, so this only owner modifier helps us to restrict the address that can talk to this function. We want only us, only the owner of this contract, to be able to change the slippage of this contract. That's the whole essence of this only owner modifier. You can see it's defined up here. So whenever anybody calls this function, this checks whether it's the owner address that calls it, and allows only the owner to do that. Now, the new slippage value comes in here, and it's compared to 0%. Of course, it can't be higher than 100%. So whenever you can change it to 99.9%. So it comes here, and then whatever, if we supply 1% in, it takes the 1% from a whole percent, so it becomes 99.9%, and that becomes the new value of our slippage number. All right, so this becomes what we use in the calculation here. All right, so the next thing we need to define is our duration. Duration has to also be a constant. It has to do with the deadline. I'm just going to write uint 256, since it's going to be a number. Uint 256 public constant. It's going to be a duration of 15 seconds. Yes, duration of 15 seconds. I think that settles it. Now, we seem to have some error. I think, okay, this is the mistake. When I was writing this function, I mistakenly deleted the curly brackets here. So it should be okay now. Yes, it is. Um, so we've defined all these variables. What Before moving on, yes, this is how we emit an event, and it's quite important that whenever you update a state variable, you emit an event. It's the standard in the industry. All right. So it's showing us error here because we've not defined this event. So I'm going to copy that. I'm going to come up here and define the event. You can see event here. I'm going to define it as events. New slippage. This is meant to be a unit 256. All right. So it should be okay now. Since we have that, it seems okay now. Yes, it's okay now. Then the next thing is this error. Now, this is how this error is to ensure that if the number we supply in is greater than the 0%, it reverts this error. And we are getting error here because we've not defined this error. It sounds rhyme, but it wasn't intentional. So I'm going to come here and define the error. And over here, it should be fine. Yeah, it's fine. So we now have an internal function that allows us to swap any token we have to another token using aerodrome v2. At this point, if you are enjoying this video, please do not forget to like and subscribe. It goes a long way in helping me to bring content like this to you. Now, if you're a business and this looks like an idea you want to incorporate into your business, or you have any other idea and you want to put on the blockchain, just check the description of this video and book a call directly with me, and we'll take it from there.